This video is going to take you through the 5 properties, there may be 6 properties of exponents. We're going to start with what I call property number 1, and we'll just progress our way through. If at any point you need to stop and rewind, please feel free to stop and rewind. So as you know, I have kinesthetics that I like to do with these videos, but the first rule is the product property or multiplication, I think is what it's called. But it's the multiplication rule. And it says that it's called the product rule, where if you multiply and they have the same base, you add the exponents for the variables that are alike. An example of this problem would be a squared b times ab to the third. I made this problem a little bit more challenging than I normally would coming out of the gate with introducing a topic, but I feel like we need to get it done and get her done efficiently. All right, so we have a squared and a, which are like variables that are being multiplied. And so we're going to add the exponents, understanding that this a has an exponent of 1. And we add the 1 with the 2, and the exponent ends up being a to the third. We're going to follow the same procedure with the b. There's a b here, which is understood to have an exponent of 1 also. And then there's also a b here. And we'll add those exponents. 3 plus 1 will be to the 4th power. And so our final product is a cubed b to the 4th. The second rule is if you are dividing, that's the quotient rule. And it says that if you are dividing and they have the same base, that you subtract the exponents. And I like to tell my students, make sure that this is the biggest exponent, the bigger exponent. So if the bigger exponent is in the numerator, that's where you will write your result. If the bigger exponent is in the denominator, that's where you will write your result. And I'm going to put 2 problems on here to show that process. All right, the first one is going to be c to the 4th over c to the 8th. This means right now that there are 4 c's that are being multiplied in the numerator. And there are 8 c's that are being multiplied in the denominator. And I'm trying to put them all here. And I'm going to put dots because it's repeated multiplication. I'm going to cancel, 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 and cancel. Once you finish canceling, you see that there are 4 c's left in the denominator. And this is multiplying by 1 because c divided by c is 1. So we're going to have 1 over c to the 4th. The short way is to say, okay, these two are the same base. So, and it's division. So I can subtract the exponents. Well, the bigger exponent is in the denominator. So I'm going to put 8 minus 4 in the denominator. And so my final result will be 1 over c to the 4th. Another problem that's a little different is 6t to the 4th over t to the 6th. Now, this problem means that there are 6 times t times t times t times t in the numerator. And in the denominator is multiplication of 6 t's. 6 will not cancel with anything. But t divided by t is 1. 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 They've been represented by multiplication. And so in the numerator, what is left is 6 times all these 1s, which is just 6, over t squared. So using the rules, we know that in the numerator, the only thing that will be left is the 6. And when it comes to subtraction, we want to subtract the big exponent minus the small exponent. And so that's 6 minus 4, which is 2. That's the second rule. Now, I was going to put all of this in one, but it's becoming quite long and I don't want it to be so long that it becomes exhausting. So let's just go over to the third screen. I want you to write these two problems down and then pause this video and try to solve it. And once you have solved it, come back and check your work. And then the second one will be 12x squared over x to the fifth. Pause the video, come back and check your work. So you pause the video, you're back to check your work. 3 times 4 is 12. And a to the fifth along with a to the second is a to the seventh. Multiplied by b squared. There was nothing to combine with the b that was in the problem. On the second problem, 12 is going to stay in the numerator because it's not being divided by anything. X and x are the same, so you're going to subtract and you're left with x to the third. A word of caution. If you have x to the third over z to the fourth, there is nothing else that you can do with this problem. This problem is as simplified as it is going to get. There is nothing else that you can do because these terms, x and z, are not alike. It's already as simple as it's going to get. Pay attention to the variables. You can only combine them if the variables are alike.